Hi everyone, welcome. In this video, we will cover what Google Colab is all about. And because Google Colab is built on top of another application called Jupyter Notebook, it makes sense to start from this page, the Wikipedia page for Project Jupyter. As it is defined here, Project Jupyter is a project to develop open source software, open standards, and services for interactive computing across multiple programming languages. And this part is important across multiple programming languages because even though Jupyter notebooks, which we will see soon, are commonly associated with Python, the reality is that the project is basically it supports multiple programming languages, so it's multilingual. In fact, the name Jupyter is a reference to the three core programming languages supported by Jupyter, which are Julia, Python, and R, basically three popular languages in machine learning and data science. And Jupyter notebooks are Project Jupyter's flagship product. They are a web-based interactive computational environment. We see an example Jupyter notebook here, and I have an example set up right here as well. So Jupyter Notebook is an open source web application that allows you to create documents that contain code, narrative text, equations, visualizations, etc. As we said, it supports multiple programming languages and is widely used in data science, scientific computing, and machine learning, etc. Now, by web application, what I mean here is that it has a web-based interface. As you can see, I'm on my browser, and it runs on a browser. However, it runs on a local server, so you don't need to connect to the internet to use it. This is run locally. As you can see, it says a local host. So it runs locally, and to run anything here, to run Python code, for example, you need a local installation of the programming languages you want to use. So in my case, I have Python installed, so I can write Python code here and it should run. Let's try. When we run, we get an output, and this was a code chunk. It automatically adds another chunk. I will call these chunks, and we could change this to Markdown to put normal text. Let's say I just wrote some Python code. And so we have, a code chunk, a text chunk, etc. Now, normally, R code and Python code are written as R scripts or Python scripts. I have an example of each from my own GitHub here. This is an example of an R script, right? And this is an example of a Python script. These are successive lines of code in the respective language in Python or R, and they are basically run one after another by the interpreter. So this format, where you just have the code itself, does not allow for easy integration of text, of figures, etc. Even though you can put comments in both languages, you can use this £sign and insert comments. Still, you can't really make the most out of narration, or you can't really put an equation that would be displayed as such, etc. And Jupyter notebooks fill in that gap where you can have both code and things other than code that are useful when you're trying to explain what you're doing to an audience in a presentable, nice format. And this brings us to Google Colab. To access Google Colab, you need to go to colab.research.google.com. And to be able to create a notebook, you will need a Google account. You will need to log in with your Google account. But once you do, you'll get access to something like this. And Google Colab is built on top of Jupyter Notebook. It uses the same IPyMB file format, and it provides a very similar interface to Jupyter Notebook. So let's create a notebook on Google Colab, and you will see how it's similar to Jupyter Notebooks. I'll go to File, and I'll say New Notebook in Drive, and it'll create a new notebook for me. We get some release notes about the recent updates to Google Colab. I'll shut this down. And then we start with a code chunk. Start coding or generate with AI. Now, while Jupyter Notebooks run on your local machine, Colab notebooks run on Google's cloud servers. So Google Colab is to Jupyter Notebooks what Google Docs are to your Office software on your own machine. So you have, Google Spreadsheets versus Microsoft Excel, right? It's like a cloud-based version of whatever you have on your machine. It's basically similar functionality, but cloud access, which is nice. So when you work with Google Colab, for example, the document is automatically saved in the cloud. It says all changes saved, and then if we change something, it'll automatically save. But you need an internet connection to access or to run it. Again, because it runs on Google's servers, to be able to run Python code or R code in Google Colab, you don't need a local installation. It'll run remotely after you connect. Now, when I say saved on the cloud, I mean whatever you put in the document, the code, the text is saved. But the runtime, meaning changes made to the computer's memory, the remote computer's memory that you have, such as variables you created or files you upload or functions you define, etc., those will not be saved. But you should create a document that can basically recreate whatever you wanted when you come back. So it should be a record of what you're doing. So when you run it again, it does what you want. Although if you have code that runs for a long time to produce some output, it would be a good idea to collect that output somehow, such as by saving in a file and then downloading it before leaving that Colab session, because your session will be reset after a while. If you come here to runtime and then go to runtime, change runtime type, you can see that you have access to two languages through Google Colab. One of them is Python, Python 3, and then the other is R. And then you also have access to some enhancements. You have access to GPUs and TPUs, which are useful when you have deep learning tasks. When you're fitting deep learning models, it makes sense to use GPU because it makes it a lot faster. For a lot of the tasks, CPU, which is the default, will just be fine. And then if you want to access premium GPUs, then you can pay for the paid version of Google Colab, and that will get you access to even better GPUs. But you have access to some free GPUs, which is great. It's great that Google provides that. So another nice aspect of Google Colab is that it comes pre-installed with libraries commonly used in data science and machine learning. So let's try. Right now we're in the Python environment. So I'll do import pandas as PD and then import DuckDB, just as examples. We didn't install anything, although Google Colab does allow you to install things, install external packages if you want to. But common data science libraries, they are pre-installed, which is pretty nice because you don't have to worry about installing them. As we said, everything resets every session. So if you need a package that you need to install, each time you come back, you would have to install. It's installable, but installing may be a little bit of a hassle. So it's good that they're pre-installed. Now, initially, when you're connecting to a Colab session, it'll take some time. But after you connect, it should be fine. In terms of timing, you won't have to, every time you run a chunk, you won't have to wait this much. Okay, because they're pre-installed, it ran without issues. You see this green tick here that says, okay, it ran successfully in 1 second. And let's try this with R as well. I'll change runtime type, save. And then now, of course, this won't run, even though it won't immediately give an error because we're not doing anything. But if we try to run this again, this won't run this time because this is not our code. So let's do some R. Let's do ggplot2, and then here, let's try these. And as you can see, that also ran without error because these packages are pre-installed, which is pretty neat. Thank you.